When I set about creating this channel, I sat down and wrote down all of the things that I would love to have happen as we start to leverage large language models to replace as many elements of human-driven software development and cybersecurity as possible. In this video, I'm going to share with you what it is, what my dream is, what my plan is at the time that I recorded, fully aware that as time goes on and large language models get better, as I develop more skills in this area, it's probably going to change. And hopefully we'll see in the future that it's going to change for the better, and I'll realize that we can go even further than I thought at the time. So I wrote down some things on a page and I'm going to read them out to you so that we can all be on the same page as we get into this. Point number 1, high quality code. I am convinced that high quality code eliminates most of the issues that cybersecurity professionals face on every day. It also allows us to have a far better way of producing code because high quality code is easier to read and easier to work with. The second thing is to have code and software that is secure by design and confirmed with testing. To be honest, I'm tired of those arguments that I've had with software developments over the years for the need for test-driven development. In my opinion, if you're going to get into developing software, every single line of code that you write and every single feature, every single user interaction should be backed by a test. You should be able to prove beyond a shadow of a doubt that 1, your feature works as intended, and 2, it takes care of common negative things that could happen to it. Take for instance one of my pet peeves, user input sanitization. It is completely crazy to me that you can have an input box on a website and not sanitize that input before it goes to your server. And yet, you'll be surprised the number of times that that still happens even today in 2026. That is completely crazy, and one of my dreams is that we develop an automated testing process that completely eliminates that as a risk from websites and all sorts of desktop apps and mobile apps moving forward. The third thing I put down is managing your vulnerabilities well. That means checking packages and your OS, your underlying OS and all of those kind of things before you release code. And once it's released, you're regularly and consistently updating it as it happens. It's crazy to me that in 2026, we can have systems that rely when a high impact vulnerability is released for a particular software package, that entire process of analyzing where it is in your environment, figuring out how to fix it, updating it, isn't completely automated. Even if you automated 50% of it to the point where you just needed humans to confirm the fix, and you did it in a completely secure testing environment, that alone would make everything better for everyone. And yet, I still find that a lot of people haven't even thought about how to do that. And then when a high impact vulnerability comes out, they have no way to respond to it and figure it out. They're trying to build it while literally things are on fire all around them. That's crazy. And so one of the things I've put down is the things I'd like to leave a legacy for in this area is to automate that complete process so that when vulnerabilities are released for software packages and operating systems, they are updated securely and properly automatically. The third thing is that I'm intensely aware that large language models are rapidly developing. So one of my dreams was to create a way for this entire system to work in a way that updated itself as it came out. When I made this video, it was a day after Anthropic's Fable model had just been released, and that was a massive upgrade in terms of software development from a large language model perspective. In order for this system to work, we need to be able to have a way that as large language models get better, they start to pick up more issues, fix more flaws, propose better solutions. The entire ecosystem has to update automatically. In a way, and not to get into the creepy AI world, we want to make sure that it's like a living, breathing entity. It's constantly improving itself, constantly updating. That's the only way that this system will actually work in the long term, because otherwise, the next model that comes out, you're going to have to start from scratch. And ultimately, that is just dead weight that you don't need. It's also a really powerful way to almost manage your technical debt as things go on. As large language models get better, as best practices are identified and implemented in these models, we are rapidly going to see a time where the need to alter individual lines of code by an individual developer is going to disappear. And that means that we have the opportunity to systematically draw down on our technical debt and eliminate it over time purely because we can focus on how these tokens are doing. It's also a really powerful way to make software development more cost efficient. The fundamental unit of compute in large language models has become a token, and the more tokens that you burn, particularly for the larger large language models, the more expensive your software development is going to be. And technical debt directly contributes to the amount of tokens you have to burn in order to fix a particular challenge or invoke a new feature. I believe that if we set up the right skills and we put them in the right ecosystem, we can make it that technical debt is actively managed and reduced over time so that you always have a cost-efficient, compute-efficient way of developing software moving forward. And I also think that makes this process far more palatable for businesses to implement. And finally, and I suppose the end goal of this entire thing for me was to see if it would be possible to develop a system that is more than the sum of its parts, to go beyond what a human could do and to actually create a system where doing this is actually the preferred method moving forward, that it creates better outcomes for people than what we get from typical software engineers. To be more secure than what we would do with your standard vulnerability engineers, to respond faster in a way that's better than your standard incident responders, to hunt for threats more effectively than what you typically see in threat hunting teams. My desire is to see if it's possible to build a compute system based on large language models, to see if it's possible to push the frontier of software development and secure software development further than we ever could have imagined. And only time's going to tell if we're going to get there. So, when I sat down and wrote these things on paper, I quickly realized that what I was talking about was far more than just one or two prompts. It was actually an ecosystem of what has come to be known as skills, all working together in concert. Here's some examples of some of the skills that I talk about in this channel and why they're useful. Proper design aligned with outcomes. Imagine you go to a prompt and you say to it, hey, I want to develop an MCP server for YouTube. Please do that for me. Standard large language model is probably just going to have a crack and do what it needs to do, forget about all the testing, all the rest of it. But ultimately, if you're a software developer watching this, that's completely ridiculous. In actual fact, you probably need to sit down almost like a project manager for a particular software thing and figure out exactly what the user wants. That skill feature alone is actually pretty powerful, and it might take you 45 minutes to figure out those requirements with the user, but when you do, you'll have a very, very, very well-ordered, well-structured thing to send off to your large language model to develop software. But it's actually a little bit more complicated than that. Imagine if you asked it to change one line of code and you had to go through that full 45-minute conversation with it to figure that out. That would actually be detrimental in the long term because people would stop using it because it's just too annoying. Then you'd end up with all of this paperwork and systems and processes to figure out when to use it or when not to. Well, if we're designing a proper way of getting these requirements, we actually need to take that into account. So that's an example of a skill that I'll be sharing in this channel. What about testing? Testing's another big one, pet peeve of mine over the years as I've dealt with software development teams and been involved at the highest levels of cybersecurity. Like, many of the issues that we come across can be solved by just implementing proper testing. Things like unit testing on all of your code, testing inputs and for good and bad outcomes, testing all of your code in a way that's robust and secure so that you don't just try and prove that it passes tests, you also prove that it's going to reject the things that shouldn't happen to it. There's like a whole episode I'm going to do on that. It'll probably turn into a whole series, to be honest. But the point here is that when you have a way of like testing your code properly, you automatically are able to eliminate entire classes of bugs, which ultimately will turn into vulnerabilities. Well, I've designed a skill that allows you to do that and ensures that every single time a PR is launched, it is done and it is tested well, and it only gets promoted into production or wherever your next branch is. It only gets promoted once it's passed all of those tests. When a test fails, it gives the developer feedback, and if you're pretty smart and cluey, you can actually set it up so that it provides that feedback back to the originating LLM, which fixes it, submits it back, and so you end up with an entire system that is constantly improving. The best part about this is that as large language models improves, the quality of the testing improves, which ultimately means that the quality of your software will improve as well. So that's an example of another one that I'll be following. There's so many more here. Talk about effective logging everywhere so that when something goes wrong, you know where it's gone wrong, you know why it's gone wrong, and ultimately you give your agent everything you need to be able to fix it. Update management, personally identifiable information removed automatically, managing your CI/CD pipeline effectively and cost effectively, and continuing to update everything as it goes on so that your model is constantly improving. For instance, one of the skills that I had a particular PR watcher that I had set up, and it was constantly failing on the lock test case. I was able to set up my skill to review that happening, and once it breached a certain threshold, it just automatically went and fixed up that PR skill and updated it. That's an example of a self-improving, self-learning system that becomes more and more powerful as you run it for longer. Then the final one, and one I'm really excited to, is threat modeling, and allowing yourself to model threats for your software for every PR that comes in, and test that your software will not be broken by those threats if they happen. That's an example of the types of things I'm doing on here, and I've done it systematically in a way that all of these skills are all working together. And I'll be sharing them for the rest of this channel. If this is of interest to you, and if you feel like this is the kind of thing that you want to get involved in, then I 100% invite you to join my channel, sign up, subscribe, hit the thing that notifies you whenever I release a new episode. And honestly, you can go to my GitHub repo, which is linked in the description, and all of these skills are there for you to download. Enjoy, and I'll see you on the next episode.